Today we'll continue with whatever we have dealt yesterday. It is design of helical gears. Design of the helical gear. Okay, yesterday, just to brief about yesterday we have solved two numericals on helical gears. One to find out the power that the gears can transmit, and second is the design of the helical gears. We'll continue with the same today. In fact, yesterday we have done only on the static strength. Now today we'll take up the complete design of the helical gears. We'll take up new numerical today. Just note down the numerical. A pair of helical gears is used to transmit 10 kilowatt power continuously with light shock loads at 720 rpm of the pinion. Pinion consisting of 20 teeth meshes with a gear having 100 teeth. Normal pressure angle is 20 degrees while the helix angle is 25 degrees. Gear is made of cast steel untreated, and the material for the pinion is forged steel C45 hardened. Design the gears. Now this design the gears could be given only from standpoint view of the bending stress, as well as they may give the complete design including the static as well as the check for the dynamic load as well. Therefore, so we'll just list down what are the things given in the statement of the problem and what we need to proceed with. Therefore, a pair of helical gear is used to transmit 10 kilowatt power. Therefore, given is power to be transmitted is 10 kilowatt. Continuously with light shock loads. Yes, this has been added to it. Therefore, we have to transmit the power continuously with light shock loads. Light shock loads. What is the use of this part? This part will decide you the service factor, that is CS, that is the loads, service factor. We'll see how that service factor to be obtained. The next is at 720 rpm of the pinion. Therefore, RPM of the pinion is 720 rpm is the RPM of the pinion, right? The pinion consisting of 20 teeth meshes with a gear having 100 teeth. Therefore, number of teeth of the pinion are given is 20, and the number of teeth on the gear is given as 100. Therefore, if you see the velocity ratio, it is about 5:1. Therefore, there is a drop in the velocity, drop in the speed by 5:1. Therefore, the normal pressure angle is 20 degrees. Therefore, given is the pressure angle is 20 degrees. Now, full depth or stub is not given. Therefore, we will take it as full depth, 20 degrees full depth. While the helix angle for the gear is given as 25 degrees. Therefore, this is the helix angle for the gear, 25 degrees. Material for the gear is given. Gear is made up of cast steel. Therefore, gear is made of cast steel. Therefore, it is made up of cast steel, or they are given untreated. Therefore, untreated, that is hardened, it is unhardened, untreated. Okay. The next is given is the material for the pinion. Therefore, pinion is made up of a different material here. The pinion is made up of forged steel C45. Therefore, it is forged steel C45. What is that? Hardened. Yes, it is given as hardened. Hardened. Okay. These are the things given. Design the gears. Yes, this is what the information given in the statement of the problem. Then with this the information we have to proceed with the numerical. Okay. Now to start with it, let us see what are the things given and how to proceed with it. So the first is power continuously with light shock loads. Therefore, if you refer to the data handbook, referring to the data handbook, if you see on page number 229, 16.21. Therefore, table number 16.21, you get the service factor. The service factor for it is, therefore, light shock loads, continuous operation, therefore 1.5 is the service factor. Therefore, service factor is 1.5. Therefore, we get the service factor here, 1.5. The next is the material properties. Material properties have been given in table 16.4. Therefore, if you refer to table 16.4, table 16.4, if you refer on page number 224, therefore, if you refer to page number 224, given is gear, it is, what is that, cast steel untreated, yes, cast steel untreated, yes, given is sigma for the gear. From this, what we get is sigma for the gear is 140 megapascal, 140 megapascal, and BHN for that is 180 BHN, 180 BHN. This is the hardness for the gear. Similarly, for the pinion is made up of 4 steel C45 hardened. Therefore, sigma for pinion from the same table, we get it is 210 megapascal, and the hardness for that it is 250 BHN, 250 BHN. For get the properties from the data handbook, correct? If you see this table 16.4, we get the properties of the material, and similarly if you refer to 16.21, you will get the service factors. Therefore, once you fix this, we will proceed with the numerical now. Okay, I will take this page, it is better. Okay. Okay, now when the materials are different, first step for the design of the gears is check the member which is the weakest member. Okay, then to decide which is strong, which is weak, we make use of sigma into y, where sigma is the static strength as well as y is nothing but the Levees form factor. And as it is a helical gear, we have to find out the virtual number of teeth and not the actual number of teeth. Based on the virtual number of teeth, we need to decide. Therefore, first let us check for the weaker component. Therefore, check for the weaker component. The weaker component. Therefore, for that we have to find out sigma into y. So, first is virtual number of teeth of the pinion. It is given by z of pinion divided by cos cube of psi. Z of pinion is 20 divided by cos cube of psi. If you solve, you get 26.87 is virtual number of teeth for the pinion. Okay, where ZP the value is given as 20 and cos psi the helix angle is 25 degrees. Similarly, if you find out Z virtual number of teeth on the gear, it is number of teeth on the gear divided by cos cube of psi, and for the gear it is 134.33. So first calculate the virtual number of teeth. Once you calculate virtual number of teeth, now make use of the Levees form factor. The Levees form factor you get in as equation number, because we have to go with the 20 degrees. It is equation 16.11b. Using 16.11b, that is 16.11b, if you refer to this equation, we can get the Levees form factor for y for the pinion. It is 0.154 minus 0.912. Instead of z, we have to write virtual number of teeth, not zp. We have to write virtual number of teeth, and for the gear pinion it is 0.12. Similarly, if you do it for the gear, y for the gear, 0.154 divided minus 0.912 divided by ZVG. You have to add, take this value, ZVG, that is 134.33. You get 0.147. Therefore, calculated both the values for the Levees form factor Yp and Yg. It is to be done only when they are different. If they are same material, yes, the pinion would be weaker and you can proceed with the problem. Next, once you get the value of Yp and Yg, now determine sigma into y for the pinion. Sigma into y for the pinion. Now, what is the value of sigma for the pinion? Pinion has a value of 210 megapascal. Therefore, it is 210 megapascal is the strength of the pinion. Y of pinion is 0.12. Therefore, if you multiply those, you get 25.2. Okay. On the similar lines, calculate the value of sigma into y for the gear. Sigma into y for the gear. The static strength for the gear, the material for the gear is cast steel, and from the table we have seen the static strength for the gear is how much given in the table is 140 megapascal. Therefore, we will take 140 megapascal. Therefore, it is 140 megapascal into y of gear, it is 0.147. 147. You will get the value of how much? 20.58. 20.58. Okay. Once you have calculated this value of sigma into y for the pinion and the gear, now you can just compare these two values. For this is 25.2 and this is 20.58. Therefore, the least for the two is the gear. Therefore, you can write sigma into y for the gear is less than sigma into y for the pinion. Therefore, design the gear. Design the gear. Therefore, all dimensions are to be calculated or fixed based on the gear, which is the first step where we have to find out which is the weaker part and we have to design for the weaker part. Therefore, this is the first step. I hope it is clear. The first step, therefore, find out virtual number of teeth, Levees equation, make use of Levees equation, get the value of Levees form factor, then stress into Levees form factor, then compare those two values and then give the decide which is to be designed. Once you design that, now next comes is the tangential load, calculation of the tangential load. Yes, we need to calculate the tangential load. Now, how to calculate the tangential load? We know the power, we know velocity, we need to get the value of velocity and then proceed with it. Therefore, I'll just rub this. Okay. Therefore, we need to know the velocity of the gear. In fact, the velocity of the pinion and the velocity of the gear are going to remain the same. Therefore, velocity of the gear, let us calculate the RPM of the gear. We know that N of G divided by N of P is nothing but Z of P divided by Z of G. Both are given in this case. RPM of the pinion is given, therefore, from this we will get RPM of the gear. Z of pinion is 20. Divided by Z of gear is 1000 into RPM of the pinion here is given 720. Therefore, it comes to be around how much? It comes to 144 RPM. 144 RPM. That is 1/5. Okay. 1/5. It comes to about 1/5. Therefore, 144 RPM is the RPM of the gear. Now let us calculate the velocity of the gear. Velocity of the gear is given as pi times diameter of the gear, RPM of the gear divided by 60. Okay. Now if you see the diameter of the gear, it is nothing but diameter is not given, but only we know the number of teeth. Neither we know the module. Therefore, this can be further be simplified as module into number of teeth of the gear into RPM of the gear divided by 60. Now, yesterday as we have seen, we are obtaining M, that is module in millimeters. Module in millimeters. Therefore, if you take only M and proceed ahead, the velocity will be millimeters per second. To obtain the value of velocity in meters per second, divide this by how much? 1000. Therefore, now, though you are substituting M in millimeters, the total solution will be in meters per second. Therefore, it will be pi M Z G. Therefore, if you substitute all those values, pi as it is, M as it is, therefore into 100, RPM is 144 divided by 60,000. Okay. If you do that, you get a velocity of 0.754 times the module in meters per second. Therefore, this is the value of the velocity of the gear. Now, once you know the velocity of the gear, we can find out the, what is that? The tangential load acting on the gear. So the tangential load, we know power is equal to tangential load into the velocity. Into velocity of the gear is the power. Okay, but it is not only simply the power is transmitted 10 kilowatt normal. The power is transmitted at small light shock loads are there. It has to be operated continuously, and we have seen that the service factor is how much? 1.5. We have taken from the table. Therefore, we have to design for 50% more than that of a capacity. That is, if 10 kilowatt is the power transmitted, we have to design the gear for 10 into 1.5. That is 15 kilowatt power. Therefore, we need to incorporate the service factor here. Therefore, this equation P into WT into SE becomes P into the service factor is equal to WT into VG. Correct? Or you can calculate the tangential load based on 10 kilowatt and multiply this tangential load with the service factor. In fact, both are the same. Therefore, here we are multiplying the power with the service factor. Therefore, if you multiply, it is 10 kilowatt, that is 10 into 10 to the power of 3 into service factor is 1.5, that is equal to tangential load into velocity of the gear is how much? 0.754 m. From this you can calculate the tangential load. If you simplify the values, you will get about 19,893.9 divided by m. That is 19,893.9 divided by m times Newton. There, this is the value of the tangential load. Now, whatever tangential load you have calculated, it is incorporating as well as the service factor also. Okay, therefore, second part is calculation of the tangential load. Therefore, the first part is check for the vector component. Second is calculation of the tangential load. This is the second step. Now, third, let us make use of the Levees equation and try to find out the dimensions. Therefore, I hope it is clear up till now. Okay. Now let us go with the Levees equation. I will rub here only and write here only. So that is better because I need those values. So next is the Levees equation. Now if you see the Levees equation, note down the Levees equation, third part. Levees equation is given by, I will write in terms of the tangential load, whereas in that handbook it is written as module equal to WT into CW, that is for lubrication factor. If you want, you can assume that lubrication factor also if you want. The lubrication factors are 1.15, 1.25 and 1.35. It is not hard and fast rule. If you want, you can also use that value of CW apart from the service factor. Okay, but here we are not taking into account that. We will only go with simple value. Therefore, CW I am taking it as 1. For the same equation, it becomes MWT will be equal to kV, that is velocity factor kV, that is the Barth's factor, into SD, that is the static strength for the gear here, where everything is based on the gear. Therefore, SD into B into M into capital Y, that is pi into Levees form factor into cos of psi. Therefore, this is the equation, Levees equation for the helical gear. Therefore, WT equal to kV SD BM into Y. Now, we will see what are values we know from this in this equation. Yes, WT we have calculated WT, therefore, we know the value of WT in terms of the module. Yes, it is in terms of the module. kV velocity factor, yes, either you can assume the value of kV, some value you can assume 0.5, 0.6 or whatever value that kV, which is nothing but the velocity factor. Else you can keep it as a kV itself, the way we have solved in the previous class, keeping kV as it is. SD, yes, we know the value of the static strength for the gear. The gear is weaker here. Therefore, as the gear is weaker, the static strength for the gear is how much? 140 megapascal is the static strength for the gear. Therefore, we know this value. B, the phase width. Phase width, the range is given. Therefore, if you see equation number, what is that? 16.26. Therefore, value of B. Value of B is 1.15 times pi m divided by tan of phi 2. It is given as 2 times px. 2 times px. Therefore, if you see that equation number, px is the axial pitch. Axial pitch is nothing but circular pitch divided by tan phi. Therefore, this becomes equation becomes PC divided by tan of phi. And we know that value of PC. What is PC? PC is equal to circumference divided by Z, or that is equal to pi times the module, because d by Z is module. Therefore, the same equation gets modified to 1.15 pi m divided by tan of phi to 2 into PC is pi m divided by tan of phi. Therefore, you get a range 7 point something to 12 point something, you get the range. You are free to assume the value of width between any value in that range. It is not hard and fast rule to assume this and this only. Therefore, a range is given, you can assume that any value in that range. As the range is vary, the phase width from one to other is going to change. Therefore, let us assume here B equal to 10 times the module. Therefore, I will assume 10 times the module. Therefore, I am assuming this. Therefore, I am writing it as assumed. Assume this value as let phase would be equal to 10 times the module. Because we don't know module, let us calculate all the dimensions in terms of module. Therefore, B is also in terms of module. This is as it is. What is the value of Y? Value of Y is pi into Y. Value is pi into Y. Y what we have to take? We are designing the gear. Therefore, you have to take Y of the gear and not Y of the pinion, because gear is the bigger component. Everything is based on gear. Therefore, you have to take Y of gear. Cos of psi we know as it is. Now, let us substitute all the values in this given equation. Okay, let us substitute and see what we get. Therefore, if you substitute all the values, I am substituting here. Therefore, WT is 19,890.9 divided by m. This is the first one. KV we don't know. Let us keep as it is. Design strength for the gear, SD for the gear, this is for the gear. The gear is 140, therefore it is 140 megapascals or Newton per millimeter square. B phase width, I am assuming the phase width as I assume the phase width at 10 times module, let it be 10 times the module. The next is M as it is the module. Y is pi times Y. Y of the gear. What is Y of gear? We have calculated using virtual number of teeth 0.147. Therefore, it is 0.147. Clear? Okay. Next is cos of psi. Cos of 25 degrees. Correct? Just check the values whether you are corrected or not. Yes, we have substituted for value of WT. KV we don't know. We keep it as it is. SD we have substituted. B we have taken it as 10 times the module. Therefore, let me keep it in brackets so that it is in single quantity. M as it is. This is the value of Y. This is cos psi. Yes, all values have been taken care. Now, if you see this equation, 1, 2, 3 and KV is unknown. Therefore, let us write it as M cube KV. M cube into KV. If you take M cube into KV and if you simplify this, you are getting it is 33.95. 33.95 is the value of M cube into KV. Okay, now we have to fix up the module and we have to do on trial and error. Correct? This is same as that of what we have done in the previous class. That is, we have done a standpoint of design of the helical gear yesterday in a standpoint of using for static strength. For the same procedure we need to use. Therefore, using that we are going ahead with this. Now, let us make a tabulation to get the value of the module by trial and error. Therefore, by trial and error. Trial and error. We have to use of the trial. Okay, now let us not trial. By trial. By trial. Now, what tabulation will make? Yes. We have to assume the value of module. Yes, module we are assuming. It is not the only method to solve the problem. Yes, you can have different methods. We can assume the value of KV. Once you assume the value of KV, you can solve it. Or you can assume some velocity. For example, assume that the velocity of the gear is less than 5 meters. KV will be 4.5 plus 4.5 V. Therefore, you can substitute that value of V in terms of module. You may get a cubic equation or whatever. You will get a equation. And you need to solve that equation to get the value of module. Therefore, there are different approaches to get the module. It is not, this is the only procedure. You can substitute the value of KV in terms of velocity. Therefore, again simplify, you may get one equation, solve that equation. Second is use some value of KV, get the value of module. Once you get the value of module, you get the dimensions. Check whether dimensions are satisfying the given condition or not. That is, whether it is satisfying the tangential load or not. That could be second method. This is one of the methods where I am keeping m cube into kV in terms of and then try to find out what is the value of module. Therefore, students are free to take up any value. Correct? Yes. I think we'll proceed. Okay. Now m is to be selected. Once you know the value of m for kV, we require the velocity. Therefore, if you see all those equations, equation number 16.32 to equation 16.35, that is 36 is for non-metallic gears, 35. Everywhere we require the velocity, therefore velocity of the gear. What is the velocity of the gear? We already found out the velocity in terms of the module. What is that value? Okay, let me just check it and put it there. Velocity is how much? 0.754 m. Therefore, it is 0.754 times the module. Therefore, this is it. Okay. Once we know the value of velocity, we can determine the value of this velocity factor kV. Yes. Therefore, we know module, we know kV. What we can estimate is m cube into kV. So let us go with m cube kV and try to go ahead with the design of the gear. Okay. Now, to start with the trial, let us start with 3 millimeters. Therefore, module is in millimeters. Let us start with 3 millimeters to start. Therefore, if you take module as 3 millimeters, 3 into 0.754, what you are getting? It is 2.262 meters per second. Okay, just write 3 into 0.754, it is 2.62. 262, yes, correct. Now 262, if you see what the value of kV you should see. Now if you refer to equation number 16.32 on page 220, for velocity less than 5 meters, therefore this is less than 5 meters, we can make use of the equation 4.5. Therefore kV we are getting it as 4.5 divided by 4.5 plus V. What is V? 2.262. Okay, if you simplify it, we are getting kV as 0.665. Yes, 0.665 is the value of kV. Therefore, we know value of m. We have determined the value of kV as 0.665. Therefore, m cube into 0.665, we get 17.96. Okay, it is come to 955 something. Therefore, round it up to 17.96. This was the first. Therefore, if you compare this value with this is not satisfying. Therefore, it is still lesser value. Therefore, if you go ahead with module of 3 millimeters, the gear may fail. Therefore, next value of could be 3.5. You can go with gradually increasing in an incremental way, 3.5, 4, 4.5. Therefore, for simplicity, I have taken it as 4. Therefore, this is the first one. Therefore, with 3. Now, let us do with 4 millimeters. Let us take module as 4 millimeters. If you take module as 4 millimeters, the velocity is going to remain same. It is independent of the module. Therefore, velocity equation is going to remain same. Therefore, 0.754 into m. If you substitute m equal to 4, there you are getting it 3.016 meters per second, which is the velocity of the gear. So once you know the value velocity of the gear, yes. Now again compare. It is still less than 5 meters per second. You can make use of this kV as 4.5. Same equation, 4.5 divided by 4.5 plus 3.016, 3.016. For that gives a value of how much? 0.599 or 0.6. It is 0.599, or you can round it off to 6. Therefore, even the rounding of errors slightly, the answers may vary, or the solution may slightly vary. However, the variation will not be too much. Therefore, kV we know. Therefore, m cube kV is 38.33. 38.33. Now, if you check this value, 38.33, yes, and this is we require 33.95. But however, with the module of 4, we are getting m cube kV as 38.33, which may satisfy our condition. Therefore, we'll go ahead with a module of how much? 4 millimeters as the module. Therefore, this we are taking and proceeding with the. Therefore, it's satisfying the given equation for m is equal to 4 millimeters. Therefore, fix the dimensions of the gear. Therefore, m is equal to 4 millimeters. Therefore, module m is equal to 4 millimeters. Therefore, similarly, diameter of the pinion, that is m into zp. M is 4. 4 into zp is how much? Value ZP is given as 20, right? Therefore, this is 80 millimeters is the diameter of the pinion. Diameter of the gear M into Z of G, that is 4 into it is 100. Therefore, 400 millimeters is the diameter of the gear. The face width, how much face width you have taken? We have taken how much we have assumed? Face width as 10 times module, yes. It is 10 times the module, that is 10 into 4, that is equal to 40 millimeters. Therefore, these are the bare minimum dimensions. Other dimensions you can addendum, dedendum and all you can fix up using the table. What is addendum, what is the value of dedendum, all those values can be fixed up using the table. Therefore, these are the minimum required dimensions that are required for the calculations. Therefore, these are the values. Okay. Now, these we have calculated based on the static strength. Now, we have to proceed with the dynamic strength. Okay. For dynamic strength, we have to make use of the Buckingham Equation. Okay. Therefore, that is the fourth step. Check for the dynamic strength. This. For we'll go with the dynamic beam strength. For dynamic, okay, approximate Buckingham equation for the dynamic load. Therefore, first we have to calculate the dynamic load. Okay, that is using Buckingham equation. Equation is given as 16.37. Equation number 16.37. Okay, this is the equation what to be used on page 220. What is that equation? Dynamic load is given by the tangential load plus the incremental load. It is WD plus the incremental load because of the shock loads and all. Because of when the gear is in working condition, it is subjected to variable loads. Therefore, this other factor, which is incremental, adds to the dynamic, that is static tangential load to give the dynamic load. What is that incremental part? It is incremental part is given by 21 times the velocity into it is BC into cos square of psi, okay, plus the tangential load into cos of psi and divided by it is 21V plus root of what is it? BC into cos square psi plus WTS. This is the equation, that is 16.37 to find out the dynamic load. Now substitute all the values. Here we need to substitute the value of the velocity of the gear. Face width is 40. Now this is that factor C. We have to calculate. We have to estimate the value of C, which is based on the error. Now how to fix that value of C? Now first we need to fix up. There are two ways to find out. One thing we have to find out the error first. Therefore, error can be obtained. Okay, I'll just go through that page. Yeah, error in the equation. If you refer to page number, what is that? Now, page number 233. Referring to page 233, table number 16.27 or 16.28. 2728, there is one more on page 232 as well. It is 16.26. Based on that, we can find out the value of error function. The permissible error in micron, it is one is on module and one is on velocity. Therefore, let us go with the module. Therefore, error E from the table 16.27. If you table 16.27. Table 16 point, I'll write it. Table 16.27 corresponding to module of 4 millimeters. We have module of 4 millimeters. Let us take class 1 gears because the speed is less. Class 2 is accurate and class 3 precision. Therefore, higher the precision, the error will come down because machining will be accurate. The lesser the errors, the lesser the dynamic loads. That is so simple. Therefore, class 1 industrial commercial gears. Therefore, let us go with 50 microns. Therefore, what the value is given in microns. Therefore, you see here it is 50 microns. If you take in millimeters, how much it will be? 50 into 10 to the power of 3 millimeters. Correct? 50 into 10 to the power of minus 6 meters into 1000. If you do, you get millimeters. Therefore, this value will be 0.0 0.05 millimeters. Correct? Therefore, this is the value of the error. So, once you know the value of error E, you can calculate the value of C using two equations. One is you can make use of the equation number just below. In the spur gear is one equation given below 16.14. Okay, that is you can refer to that equation. C equal to AE divided by 1 plus EG plus 1 plus 1 by EP. Yes, you can make use of it. Is given on page number 219. If you want, you can just refer that page number 219. Or from the table you can find out the value of C. The table is 16.5. Therefore, what is the table? Now let us make use of the table here to get the value of 16.5. Therefore, if you refer to number 16.5, therefore value of C are obtained from table 16.5. If you refer to table, that is dynamic load equation, to be C value in dynamic load. Material is given, therefore material is steel and steel, cast steel and steel, both are steel and steel. 20 degrees full depth. Okay, if you go with steel 20 degrees full depth, we are getting corresponding to value of E equal to 0.05. So if you see here, it is steel and steel combination, full depth 20 degrees, therefore 0.025, 0.025, then 0.05. The value of C is how much? 605. Therefore, value of C is 605. Therefore, we got a value of C from the equation for 20 degrees full depth. Okay. Once you know the value of C, now substitute in that given equation. Therefore, substitute in that given equation. If you substitute in the given equation, for this equation, where substitute the value of velocity of the gear corresponding to module equal to m equal to 4, we know the value of, now yes, we have to calculate the tangential load now. Therefore, if you calculate the tangential load, we know the tangential load WT is equal to how much it was? 19 something, 19,000. Yes, 19,893. 19,893.9 divided by m. M is equal to 4 millimeters. Therefore, if you substitute m equal to 4, you get this value as 4973.47 Newton. Therefore, this is the value of the tangential load that is going to come. For make use of 4973.47 in this, substitute all the values of B, C, the helix angle plus WT, all the values if you substitute, okay, and determine the value of WD. The value of WD, you are getting it as 11,428.83 Newtons. Therefore, this is the value of dynamic load that is going to come onto the gear tooth, 11,428 Newtons. Clear? Okay, let me see the time. 20 minutes. 11,428.83 Newtons. This is the value of dynamic load. So once you calculate the dynamic load, now this dynamic load has to be checked with the dynamic beam strength for the strength, bending stress, as well as for the wear. Therefore, first let us go with the dynamic beam strength. Therefore, dynamic beam strength. Dynamic beam strength. If you see that dynamic beam strength, equation number 16.38. Therefore, equation number 16.38. The value of this is given as WB is equal to SDR into B, right? SDR B y m cos of psi. Therefore, it is the same equation, Levees equation. Instead of, we are not taking the velocity factor here, and here this is the endurance limit of the material. It is fluctuating load, dynamic. Therefore, we can't take the static load. We have to take the endurance limit. B you know, y you know, m as it is into cos phi. Now, how to get this value of endurance limit? Now, endurance limit may be given in the statement of the problem, or in the, if you know the material, you can get the value of the endurance limit. Or if you just refer to table number 16.20, therefore equation using table 16.20, table number 16.20 for the steels. Yes, they are given the value of endurance limits here for it. Therefore, if you know the value of BHN for the gear is how much? 180, corresponding to value of 180, it is about how much? Yes, 175 to 195. Or you can make use of this equation SCN equal to 1.76 times BHN. That is better. Therefore, I'll write SCN, which is given as SCN, actually SDR, 1.76 times BHN. Therefore, if you make use of that value, SCN equal to 1.76 times BHN, this is the value of endurance limit. If you make use of, how much we get? We get it is at 316.180, therefore 316.8 megapascal. This is the value of endurance limit, 1.76 times BHN. This for the steel that is given, or SN equal to 700 megapascal, or the value is given between this to this. Okay, based on the hardness. If you see minimum, it is minimum hardness 180. The helical gears SCN endurance limit megapascal 175 to 195, whereas here we get as 316.8. We'll go with 316.8, making use of that equation. Therefore, if you make use of 316.8 and substitute in this given equation SDR, okay, if you make use of that value, and B is 40 millimeters, you know value of Y is equal to pi into Y of the gear. M module is 4 millimeters into cos of phi into cos phi. If you substitute, you get the value equal to how much? You get the value as 21215.25 megapascal. Sorry, newtons. It is W. 21,215. Therefore, I am substituting here as 316. Phase width as 40. Pi into Y is 0.147 into module is 4 millimeters into cos of 25. We get as 21,475. If you compare this value with this value, 11,429. If the endurance limit of the material is 316.8 megapascal, actually this is going to be greater than the dynamic load. Therefore, it is safe. Therefore, as far as dynamic load, the value is on the safer side. Okay. So next is the wear load. Check for wear. Wear load. Check for the wear. Now for the wear, yes, you have to make use of the equation. Which equation you make use of? For the wear, yes, I'll just see the equation for the wear. Yes, equation for the wear is given as equation 16.39. For equation 16.39, this is the equation, sorry. Equation 16.39 you have to make use of, where wear load equal to K times load stress factor into B into pinion into Q divided by cos square of phi. Cos square of psi. This is the equation for the wear load. Now, how to get the value of K? Yes, the value of K can be obtained by two ways. One is referring to the table. If you refer to the table, table number 16.23, based on the hardness, you can find the value of 2. Whereas hardness is 180 and the other hardness is how much? 180 and 250. Therefore, 180 and 250 is not given here. 200 and 250 is given, corresponding to value of 20 degrees. It comes to about 0.722. Okay, hardness is 200 and 250. Steel combination. It's 0.722. Or you can make use of this equation, which is that equation in the spur gear. Yes, we have one equation in the spur gear. What is that equation in the spur gear? It is given as K equal to, yes, we'll make use of that equation, K equal to. Okay, this part is over. I'll continue here. Okay, this is over. For the wear load, I'll get the value of K here. K equal to, you can write it as SFE square, that is surface endurance limit, into sine of phi n, that is in the normal plane, that is the pressure angle in the normal plane, divided by 1.4 into 1 divided by EP, that is Young's modulus for the gear, plus 1 by EG, that is Young's modulus for the pinion and the Young's modulus for the gear. This is what to be equation to be used. So for SFE square. Now how to get the value of SFE? This is a surface endurance limit into sine of phi n. Value of phi n is given 20 is 1.4. EP and EG, yes, both are of steel. Therefore, you can assume the value. Let us assume it as 2 to the power 5 megapascal. I am using the Young's modulus. You can take 2 or 2 into 10 to the power 5 also. SFE square is one of the important thing. Now SFE square can also be found out from the table. Surface endurance limit. Therefore, if you refer to the table, yes, on page 230, SFE, page 230, equation table number 16.22. For table 16.22, if you refer to this table in the HG Patil data handbook 16.22, it is given SFE is for the steels 2.8 BHN minus 70. It is given as 2.8 BHN minus 70. You can calculate the value of SFE. Therefore, I have calculated the value, and or the value of K can also be obtained. If you see the helical gear, they have given one table the below just itself. This can be found out, or you can directly get the value of K as what is that? 0.16 into BHN divided by 100 its square. If it is of steel and steel combination, below equation itself, where equation here is given. Therefore, let me substitute the value of BHN of the gear here. If you substitute the value of BHN of the gear, that is 180. What we are going to get the value of K as 0.5184. 5184. Therefore, K can be obtained by different methods. One by the table, one by this equation, and second is by this equation is given in the data handbook. Therefore, I am making use of the equation just given below 16.39. It is below given on the page number 221. This is given on page 221. We got the value of K, the value of Q. The value of Q to be obtained by making use of 2 times dg plus dp plus dg. Sorry, I am writing one below the other, therefore you have to keep a track of it. Therefore, this is over, dynamic beam strength, and here is it. Let me work with it. Therefore, in this equation now I want the value of Q. Therefore, Q is equal to 2 times dg divided by dg plus dp, or it is nothing but in terms of the mod 2 times zg divided by zg plus dp for the external gears, and for the internal gear negative, assuming both are external gears. If you substitute the value, you get the value of Q. Therefore, let me substitute here. If you substitute those dimensions of the gear and 2 into diameter of the gear, how much we have got? We have got about 400. Yes, 400. Or and this is 400 plus the diameter of the pinion is 80. Or you get them in terms of number of teeth as well. You get how much? Q 1.67. Therefore, you get it as 1.67 is the value of Q. Now, in this equation, if you know wear load, yes, wear load, I'll write it here. Sorry, wear load is equal to, it is given as K B dP into Q divided by cos square of psi. Cos square of psi. Substituting all the values, K as 0.5184, B face width is 40, dP, or you know diameter of the pinion also we have written as 80 millimeters. Q we have calculated 1.67 divided by cos square of phi. Okay, do this. How much you get? Just try it. Probably you get 3372.71 newtons. Okay, this is what you are going to get. 3372 newtons. But this has to be greater than the value of dynamic load. Okay, if you see, that has to be more than the dynamic load. Is it more than dynamic load? Yeah? No. It is less than the dynamic load. Therefore, the gear is going to fail because of the wear. Therefore, there is going to be wear failure. Failure due to wear. Failure due to wear. Due to wear. Now, how to change? How to make it? Yes? How to improve? Wear. When you are talking of wear, it is due to the relative motion that is taking between the two teeth. There is rubbing. One is going to slide over to the other. One teeth is going to slide over to the other. Though there is amount of lubrication, there will be slight amount of wear and tear. If you increase the hardness of the teeth, naturally higher the hardness, less is the wear. That is, more is the wear resistance. Therefore, you have to increase the hardness. Now, when you are increasing hardness, this is one value which is dealing with the hardness. We have to improve this value of K. Now, how to improve? What should be the value of K? You can go in trial and error and go on increasing the value of K, increasing the hardness, and find out what should be the limiting value. Limiting value is this much. I should get at least this much, 11425, 428. Therefore, what we'll do is we'll equate this wear load to the dynamic load. So what is that wear load? It is KB dP into Q divided by cos square of psi should be equal to dynamic load. How much? At least this much, 11428. Okay. Now here we know we are see there are different ways of increasing. Either you can improve the value of B, you can improve the value of dP. You can therefore by increasing the value of B, you are increasing the size of the gear. Diameter, yes, you are still increasing the diameter of the gear. Size is increased. Keeping the size same by just changing the hardness, yes, we can take care of the wear load. Therefore, it is better to always improve the value of K rather than increasing B and dP. Okay, however, even if you increase the value of dP, you can see here the value of Q won't reduce. Therefore, there will be indirect reduction. Therefore, if you increase, I will keep B as it is 40, dP is 80, Q as it is. How much is 1.67? Cos phi is recalculate the value of K. If you recalculate the value of K, K comes to be about how much? 1.76. 1.76. 1.76 is the value of K. Okay. Now what you do is now refer to the table. Now refer to the table and try to fix up the value of K. Now refer to the table on page number, yes, on page number 230. Refer to page number 230. You know value of K for 20 degrees. I will search now 1.76. If I go on searching for 1.76, it comes to about yes 1.78 20 degrees. If you refer to table 16.23, we are getting 1.78 for 20 degrees. So let us adopt that 1.78. Now with 1.78, if you see, for the gear it has to be 300 and for the pinion it has to be 400. Therefore, using the table, we can fix it. What is the table number? Table number 16.23. 16.23. 16.23. K we are taking it as 1.78. Therefore, BHN for the gear, we should be 300, and BHN for the pinion, because both are steel. BHN for the pinion, how much it would be? BHN for the pinion, it will come to about 400. 400. This is what we are suggesting. Therefore, if the gear is having 180 BHN and similarly the pinion having about 250, whatever we have estimated from the properties given as 250, it will not withstand, it is going to wear out. Therefore, at least the gear and the pinion has to be of this hardness. So now we have completed the complete design of the gear, taking into account the static load. With the static load, we have calculated the dimensions. Once we calculate the dimensions, now we have to check for whether they will withstand, be safer in the dynamic load. Therefore, we calculated the dynamic load using Buckingham equation. In the Buckingham equation, we have to find out the value of load stress factor C. Therefore, value of C. Therefore, this value of C can be calculated using the table. Therefore, 1 minute. The value of C, that is the dynamic form factor. The dynamic form factor. Okay, it's called dynamic form factor or dynamic factor form factor obtained from table number. Yes, the table number C. Yes, it is obtained from table number 16.5. Use that, get the value of WD. Then go for the dynamic beam strength. Make use of the equation 16.38. Check whether it is greater than WD. Yes, in this case it was greater than WD. It was safe. Next, check for the wear load. For that, we have to find out the value of K, where that is load stress factor K. How to calculate the load stress factor? One is using that table 16.23. Second is using the equation of using SFE, that is surface enclosure, that is 16.16a. Therefore, this one you have to make use of in equation 16.16a. 16.16a. If you make use of in that equation, you can calculate the value of K. Or in the helical gears, especially it is given if both are made up of steel. If both are made up of steel, it is given as 0.16 BHN square by 100. Therefore, let me make use of that. You get the value of K. Substitute the value of K, B, dP, Q, and you get the value. Check whether it's greater than that. It is less than this. Therefore, our suggestion would be to increase the value of the hardness. Therefore, recalculate the hardness. What is the limiting value? limiting value should be this much. In fact, it should be more than that. Limiting value, equate it. Keeping all same, calculate the value of k. Now refer to table number 16.23, which is the table for the load stress factor. Okay, corresponding to 20 degrees, go on searching where is the value of 1.78. If we get 1.78, because you have to go, they are given material steel, cast iron. Check for the material, both are steel only. Okay, you may get 1.7 in other categories also. So for 1.78 for steel and steel, therefore you get gear as 300 BHN and 400 as this is what we are suggesting, and this is how you have to complete the design of helical gears. I hope this is clear. Okay, practice some more numericals on this. Okay, we'll close today and take up a similar type of numerical in the next class tomorrow. Thank you. Okay, thank you.